Well, your solution, you can write b dv equals f over m dx, right? And you integrate that, and you get v squared equals f over m times x plus a constant. 2. Okay? Antiderivative is v squared over 2. So it's really straightforward, right? Okay? Now that's consistent with what you get. Okay? Okay? Don't want to use C, don't want to use gamma. Well, I'm going to use a C here, but this C is different than this one. Okay? You just pulled out your dynamics book,
Yeah.
didn't you?
Yeah.
And you pointed to something,
Yeah.
which is this.
Yeah, it is.
Okay? Now, is this consistent with this?
You said the C was different, didn't you?
Well, huh?
It's still a constant, right? The C?
Well, but different constants. Okay, well, okay. We can say that, okay, well, if v of 0, well, this means that v equals f over m times t plus v of 0. Whatever v of 0 is, v is a function of t. If we let t equal 0, we're going to get v of 0, right? We're going to get v of 0 equals c. Okay? That's just your initial condition. Okay? Now, if v equals this, that implies that dx dt equals 1/2 f over m t squared plus v of 0 t plus another constant, which I'll still call c, because I've evaluated this c, it's not there anymore, okay? Just because I don't want to go through the whole alphabet for constants, and c kind of denotes constant. As long as you realize that the constant is, and, you know, I wrote the solution. Okay? In other words, v is dx dt, so we integrate both sides with respect to t, and we get this, okay? You don't even actually need to do it as a differential equation. Okay? If you know the antiderivative, the velocity function is the position function. So there we have it, okay? Now, is this consistent with this? Well, I could have written okay. Can you read that?
Yeah.
Now, is this consistent with this? And it's not t, it's x, because, of course, we solved in terms of x. Okay? Well, if we plug this x in here, then we get v as a function of t, right?
Yeah.
Okay. Well, a little bit of trickery with v of 0, okay? If you use the plus here, okay, because this would still be c. Okay, let's just put that as c. Okay, in the plus case, when x equals 0, you got some velocity c. Now, you get into a little detail about what happens when x equals 0, okay? Does that happen when t equals 0? Okay? And actually I wrote that as v of 0, it should be x of 0, but I don't want to get into the messings of it, okay? I'm saying this is consistent with this, okay? And I'm going to let you think through things in home, okay? Let you think through the way this constant works in a home problem. Because the way I've got it written out here is getting messy. I should have left myself more room. I don't want to get the board any messier than I've already got it, okay? But you have these two solutions and they're consistent. Now, what I really want to get to is this idea that the rate of change of velocity is velocity times, the rate of change of velocity with respect to time is velocity times the rate of change of velocity with respect to x. Okay? So, we want to talk about what this means.